So, hope everyone had a great weekend. Just to remind you all, we have the second lab due today at 11:59 p.m. So, make sure that you submit it by then. We'll probably have time, maybe about 10, 20 minutes to just kind of go over the lab if we need to. What I'll probably do is just end class. If you have any questions, I'm happy to address them. Apart from that, we've got office hour at 10 a.m. So, if I don't get to you by 10, I'll be at my office. Well, my lab, not my office, but you guys know the drill there. So last class we wrapped up with Prescriptive Analytics. Just a brief little review. This is where we describe the data. We're not doing any analysis. So things like mean, median, mode, what the data says. So we're going to talk about next is all about the predictive analytics, what we think will happen. And this is where we really get into predictive analytics. So this is where we use trend analysis, maybe, some sort of forecasting, regression. These are all examples of predictive analysis. And of course, we're going to be doing these in just a little bit here. So don't concern yourself too much for the time being. Just understand that this is what we're talking about. We're actually building a model, using it to predict some outcome. Okay, so some different types of forecasts we're going to be using. A naive forecast is just going to literally take the previous value and assume that it's going to be the next value. That's going to be the forecast using the naive method. Not up here, seasonal naive is where we take the previous forecast of the same period. So for example, we have quarterly data. Just briefly draw out some quarterly data here, say quarter, and then year. So we have quarter 1, 2, 3, 4. And we want to predict, so year 1, 1, 1, 1, 2. Okay, and then we'll have some values associated, so we'll just say 100, 200, 300, 400. Totally made up, obviously. Okay, so the naive forecast for quarter 1, year 2, you're just going to literally go to the previous value. So it's going to be this guy right here. So it's going to be 400 for naive. If we're doing seasonal naive, we'd come up here to the most recent quarter of the same, or the most recent period of the same type of period. So go back to quarter 1 of year 1. It's going to be 100 for the seasonal naive. Okay, simple moving average is going to be where we take some average of the most recent occurring values. Typically, we're going to use a 3-period simple moving average. We don't have to use a 3-period simple moving average. We could use a 5-period if we wanted to. You could use a 2-period. You could theoretically also use a 1-period moving average. Now, if we're using a 1-period moving average, what is that going to be the same value as? Yeah. So it's going to be the same value as the naive. Okay, because if we're using 1 period, we're averaging the most recent period, same as taking the most recent period. Does that make sense? So, you'll be given how many periods you're going to use. If you're not given, assume 3. That's what we're talking about there. Weighted moving average is pretty similar, only we have weights that add up to 1. So if we're taking a 3-period weighted moving average, we have 3 separate weights. We have weight 1, weight 2, and weight 3. Okay, you'll be given the different weights, and they must add up to 1. So we have sum of weights from 1 to however many, or I guess we should do 1 to n, going to equal 1. Okay, does that make sense to everyone? Because if it don't equal 1 and we're multiplying by them, we're getting something that doesn't add up to 1. We're changing the inherent values with that. So that's what we're talking about weighted moving average. We have different weights. Let's say this were equal to 0.1. Let's say this were equal to 0.4. And let's say this guy were equal to 0.5. We just take the most recent occurring values and just multiply them by the respective weights. So that's all we're doing there. You got a question? We're doing a seating chart today. Just pick an empty seat. So basically, that's what we're talking about there. Of course, we have simple exponential smoothing. Simple exponential smoothing, we have some alpha. The alpha must be between, it doesn't have to be between 0 and 1. It can literally be 0. It can also literally be 1. So we have 0, we have 1. So that's what our alpha is. And of course, we multiply the previous value by alpha, and we multiply the previous forecasted value by alpha minus 1. So any value we have here, we have alpha. Of course, we have alpha minus 1 for we're multiplying our forecast by. Seasonality forecasting is where we're going to be looking at it as opposed to the season. So we'll do some examples of that. Basically, this is where we're going to be predicting future values based upon what we expect to see from a seasonal perspective. So we'll get into seasonal constants and all that sort of good stuff in just a little bit. Trend forecasting is where we're doing a very similar thing to seasonality. Only with seasonality, we're focused on 1 year. Okay, 1 year, start to end. So the year can start wherever. It can start in July. It can start in January. It can start in November. It doesn't matter. But we're looking at a period of 12 months. Does not matter if it's quarterly data, weekly data, whatever we have. Seasonality will always be concerned with 1 year. Trend will be concerned with changes over time. We're talking about over time. We're talking about between 1 and 5 years. Can include 1. Can include 5 as well. But basically, we're just going to be applying some sort of growth, looking at that and seeing what that does. So that's all about the simple forecasts. We'll be doing some examples of these. Don't worry about them too much. They'll make more sense once we apply them. Let me go back. Are there any questions about simple forecasts? Anything I need to repeat? Like I said, make sure you take notes. This will be on the exam. So, this is basically the way you get them. You can also, of course, look stuff up yourself, but that's, if you want to have it as it's taught in class, make sure you take notes. All right, prescriptive analytics is kind of in a way similar to some of the previous, but this is where we actually recommend an action. So as opposed to just predicting something with prescriptive, this is where we're actually going to recommend an action. So think about if you have a car. Okay, who's learned to drive in here? Anyone know how to drive? Okay, hopefully most of you. When you're learning the process of driving, what do they teach you? What's that 4-step process? It's on the board. I'll give you a hint. Identify, predict, decide, and execute. Okay, so we've already done identify. Okay, think about the identification process when you're driving. Okay, what are you doing? You're looking around, you're scanning your surroundings, you're seeing what hazards may present. You're seeing, are the roads clear? Do I have enough distance from the vehicle in front of me? Am I going to be involved in a collision? Okay, you want to avoid that. Okay, so that's where you're identifying. You're seeing what is around. You're not making any predictions of what will happen. You're seeing, what are my surroundings? Okay, then you predict. You see a deer on the side of the road. What do? Slow down, maybe. Kind of look at it a little bit. Make sure it's not about to jump out in front of you. Okay? Decide what you do. This is where we're inside of the prescriptive now. So think back a couple slides. Descriptive, that's all about identification. What is there? Prescriptive, what do we think is going to happen with it? Okay? And then lastly, prescriptive is what do we do about it? So decide and execute. Okay, that's all this is about. So think about a DSS. It's probably going to be operating inside of the prescriptive category. So, something where it's going to have a bunch of inputs and tell us what's likely to be the output. It's prescriptive. Okay. So if we're talking about this in the context of a supply chain, this is where we take action. So if we have all of our inputs and we know what is likely to happen, let's say we predict that demand will decrease. What do we do in a supply chain? Do we ramp up the production? Do we slow it down? Do we try to eliminate some of the variable costs? What do we do? Slow down production however you can. Trying to keep the marginal cost per item as low as possible. It can be difficult to do if you have an economy of scale and you have a prediction that you will go down. So you take that action up. Is it an easy action to take? Probably not. But that's all this is talking about here. So everyone clear on the differences in the types of analytics? Well, like I said, we will mostly be inside of predictive, predicting what will happen. Reacting to what will happen, a little bit outside the scope of this class. I don't know if they have like some sort of supply chain class that you guys have to take. Do you guys know? You guys take a supply chain class? Like operations management, anything like that? Well, take a look at the curriculum. Maybe you will, maybe you won't. I don't know. So just kind of wrap things up. We talked about managers and the decision-making process. Talked about the business analytic process. Talked about 3 different types of analytics. And we also talked about presentations. So Any questions before we jump into the material for Excel today? All right, as always, I'm happy to address any questions. So we're just going to be inside the file. Really, pretty much any of the files will work. But basically, I just have the version pulled up that we used most recently for the pivot tables. So if you'll just go ahead and pull this up, and then we'll do one example of this today, and we will finish up with doing some more examples on Wednesday. I want to give everyone just a little bit of time to sort of make sure they have the lab at a good spot. So we'll probably wrap up about 20 minutes left or so, give or take. So is that cool with everyone? All right. So like I said, just go ahead and pull up any of the versions that we've used. They all have this data set, so no big worries. I'll give you just a couple minutes to do that, and then we'll begin. Question? Just hold down the power button and then turn it back on. Give it about 20 seconds. Hold down the power button on it. And I will, at the end of the day, I'll make sure to post this file. It's called like Analytics 1 class, because next class we'll basically finish off this file. And that'll pretty much actually be the end of this unit for the most part. Let's go over the schedule briefly. So we're going to come in here Wednesday, finish everything up with Excel. Got an article discussion. I will find that today and put that in Canvas, so you'll have some days to read through it. We will review for the exam Monday, so make sure you come with any questions between now and Monday. At some point when I get a chance, I will post a study guide that will have all the terms, everything to know for this class. So, recommend you come with any questions, anything like that. The actual exam will be Wednesday, so next Wednesday. And that will, of course, be closed book, closed note. Proctored, taken in here. You don't want to miss it. Friday, there's like a mini break or something, so, go out, have a good time, whatever. And we'll pick up on Monday, October 4th with databases. So has everyone had a chance to pull up the spreadsheet? All right. Let's go ahead and jump into this. So you can tell we have year, month, and count. Okay, this is a panel. Okay, so basically we have time variable. We have different x's associated with that. Thank you. Did everyone get a chance to sign this guy? So if you didn't get a chance, just make sure you get it. So what we're going to do first is we have count. That's how many of whatever they're selling were sold. So in this case, we're going to assume it's actually a service as opposed to a physical product. Okay, and we have fixed cost. If you come down to the bottom of this here, at the bottom of this monthly data, we have fixed cost of $1,200 a month. Okay, and we have a very variable number that we sell, whatever service we have. So all we have to do to calculate the product cost per month is going to give us the marginal cost. Just take that $1,200 and just divide it by the count of how many you sold. So in this case, all we have to do is just take that 1,200, divide it, and that's going to give us almost 45 cents per. Just copy this down. And this gives us the monthly marginal cost. Does that make sense? So if I sell this many, this is what the marginal cost is per day. And that's because it's a fixed cost. So the $1,200 a month, let's assume that's a staff expense. Okay? And to provide the service that we provide, whatever it may be, there are no variable costs. It's only fixed. So, on this class, I'll keep it nice and simple, but just understand in the real world, you'll probably face examples far more complicated than a single fixed cost. Does that make sense? So that's all we're doing to determine the product cost. If we wanted to, we could certainly put this into accounting format, although we don't have to. Okay. Everyone with me to this point? All right, so now we want to calculate the sum by year. So we have year 1, you can see we have these right here, year 2, year 3. Okay, so we want to add up how many we sold by each year. What are some different ways we could do this? Well, I'll tell you, one of them is to just take this cell, add it into this cell, and we could do that all the way down. Is that the best way to do this? What are some better ways to do this? We could use our good friend the sum, and we could take the sum of year 1 and manually set these ranges. Is that the best way to do it? It's not the best way. Who could tell me the best way to do this? So exactly, so our range is going to be the year. So we're just going to look for, in this case, 1. Because we want year 1, we know that it's in the format of 1, 2, 3, so on. And then we actually want to add up the C column because that's where we actually have our sales. So the number that we sold is inside of C. Let's make sure we use that for sum range. And just go ahead and copy this down 3 because we don't have year 4. Now you'll notice that when I copied this down, it didn't change the criteria. So all I want to do is just go into the year 2 and just change the criteria to be a 2. And for year 3, change the criteria to be a 3. Okay, does that make sense to everyone? Like I said, feel free to stop me with any questions. Like I said, trend is going to be a pattern over time. Okay, so if we're going through time, we're saying how much are we growing each year? Okay, and we're going to express this as a percentage. So just make sure this cell is labeled a percentage. Okay, and then all we have to do, just go ahead and start off a good equation here. Open up 2 parentheses. Grab this F4 right here. We're going to divide it by year 1. Of course, we're going to subtract 1 from this because we're wanting to get the 1 out so that we can use this as a percentage as opposed to having it be 128%, for example. Just close this off, and then because we have 2 years we're going from year 1 to year 2 to year 3. That's a total of 2 years change, just divide by 2. And that gives us 28%. Okay, so all we did is we just took this number down here, divided by this number. Like I said, we subtract 1 because if we don't, that's going to be 128%. Does that make sense? So that's all we have to do there. Everyone got this? All right. So basically, we're growing on average 28% a year. Is that good? I think it's pretty good. Is it amazing? Maybe not amazing, but it's pretty decent. So, basically that's what we're doing there. Now we want to do average by month. Okay, like I said, there's a couple different ways we could do this. There's not a right way to do it, but there's an easier way to do it. So what I could do is I could do average of this, and I'm just getting all the Januaries basically, and this. Will this work? Yeah, of course it'll work. Give me the average of January, and I could probably copy this down, and it would probably work just fine. But is that the easiest way to do things? What's an easier way to calculate the average than that? So, and keep in mind, I have 3 terms for each of these because there's 3 years, and we're in quarterly or monthly data. But what's an easier way to calculate the average by each month? If I had, say, more than 3 months that were averaging together. Let's say I had 1,000 months. Then what would I do? That's exactly right. Average if. We'll take average if. We know we first want to get the range. It's going to be the range that the criteria is in. So we're just going to grab the month column. All we have to do, because January is inside the data set, February, so on and so forth, we can just use a relative reference to this cell J2 and then just copy it down as we go. So then the average range, obviously we're going to average the counts. So we just go ahead and grab a count for the average range. And then we can just copy this down. So like I say, for the range, it's going to be the month because that's where the criteria is. The criteria is going to be J2, January. So if it's January, it's going to average it. Does that make sense to everyone? Just want to make sure everyone's on the same page there. So like I said, we just copy this guy down. And it's going to be the better way to do things. Because like I said, With 3, it's not that hard to grab 3 and then copy it down in a panel like this. But with 3,000, it's a lot harder. You're not going to want to go through 3,000 things and grab them, and you're not going to do it perfectly anyway. So it's much better to use average if. Okay, so now we're going to just add up everything. That's going to be the grand total. Okay, so grand total, all we have to do is just add up everything that we have. So I'm just going to grab the count column right here. And that gives us 80,848. So up to this point, it's been pretty straightforward. It's pretty much been a review of everything, right? Nothing really new at this stage. Where it gets a little bit more interesting is when we start doing things like seasonal constant, seeing what proportion of the variation is explained, or rather, what proportion of the sales are included inside of each period. So we have the average by month, okay? So we know that the average monthly sales of January is 2,803. Okay, the average monthly sales in July, 2,341.3 repeating. Okay, so now we just say of the total, which we're going to take this number divided by 3 because we have 3 years inside the grand total, and we're just going to divide this number into this number divided by 3. Does that make sense? So if we want to, we can do this a couple different ways. We could go ahead and divide this guy right here by 3 because there's 3 years. That's one way we could do this. Another way we could do this, if we wanted, would just be to take the sum of the averages. Okay, and that gives us the same exact value, of course, because we're either adding in the averages, which I already have the 3 divided out of them, or we're taking the total of the cost and then dividing the 3 out of it. Either way, it's the same thing. Does that make sense? So let's keep things nice and easy. I'm just going to go ahead and leave this as the sum of the averages. And then, all we have to do now for the seasonal constant, just take each month and divide it by the grand total, which obviously we want to make sure that has an absolute reference around it. And now who can tell me what these seasonal constants should add to? 1, exactly. Because if they don't add to 1, as we begin to multiply things by them, what's going to happen? We're going to be multiplying by something other than 1. And that's not what we want to do for forecasting. We always want to multiply by 1 if we have some sort of same thing like the alpha down here for the simple exponential smoothing, 0 to 1. Anything larger or smaller than that, we're not multiplying by 1. The weights, no matter how many weights we have, they got to add to 1. Does that make sense to everyone? For the seasonal constant? So all you guys to do is just take the average by the month and just divide it by that number. So if you just use the sum of the count, you have to divide it by 3. You could also take the average or the sum of the averages. Does that make sense? Yeah, well, you want to use an absolute reference on that because as you copy it down, you don't want that to change. All right, question? So basically, to do the seasonal constant, you could leave it and just divide by 3 inside of this calculation. I just find it a little bit easier to divide the grand total by 3 because there's 3 years in total. So either way, for the seasonal constant, if you didn't do that, this would add to 3. Or actually, it would add to 0.3 repeating, actually. Any other questions? All right, so like I said, basically what this is saying is that 10% of our sales come in January. Okay, all this adds up to 100%. So we don't have a lot of sales in December. We don't have a lot of sales in November. We have a much relative higher in August and January. Does that make sense? So if we take 1 and divide it by 12, we get something around 0.8. Okay, not exactly 0.8, but something around there. Or 0.08 rather. I should be very clear about that. So if it's larger than that 0.08, what do we know about it? If one of these seasonal constants is larger than the average seasonal constant, What does that tell us? It means that that's a month that we expect to do more business than others. So if we have stuff that's not right around the seasonal constant, it suggests that our data has some seasonality to it. Okay, so in this case, we were to plot this out. Okay, so if we're starting in January and we're ending in December, what's this going to look like? So we say this right here is going to be the average. Okay, so January, we're somewhere up here. Okay, then we go down to February, somewhere down here. March, a little bit higher. April, a little bit above average, but not much. May, slightly below. June, right around average. We'll call it average. Why not? July, a little bit higher. August, way higher. Okay, and well, this doesn't quite end at December, but just kind of get the idea. Does that kind of make sense to everyone? So all you have to do is take 1 divided by how many periods you have. You have 52 periods for 52 weeks. Let's take 1 divided by that. It's going to give you the average that you would expect to see with no seasonality at all. Does that make sense? So that's how you calculate the seasonal constant. Just take your averages divided by the average for a year. All right. So now what we can do is we can actually apply some basic trend analysis and add in seasonality with this as well. So basically all we have to do is just take our previous observation for year 3 to predict year 4 using trend. We're just going to multiply it by, in this case, let's use 1 plus the average annual trend. Okay, and that gives us about 41,000. Okay, so all we did, take the previous observation. We know that we're growing on average 28% a year. So just take 1 plus the 28%. Okay, and the reason we do the 1 plus is because we're multiplying by 0.28. Okay, if we multiply by 0.28, is that going to be larger or smaller than expected? Much smaller. Instead of adding to it, it's just going to take away. So instead of having like 31,000, we'd have somewhere around like 10,000, somewhere around there. So all you guys to do, just add 1 to that. So we're going to be multiplying by 1.28 because we're growing by 28% a year. Take that. Is that clear? All right. So now we have what we expect the entire year's sales to be, and we also have the seasonal constant. So who wants to take a guess at how we're going to calculate what we expect the year 4 to be for each of these months? How are we going to calculate that? So if we know what we expect the total sale, the number of sales to be, and we know what proportion is explained by the month, how do we get the average or the predicted sales for each of these months? How do we do that? So we know that the sales are going to be this, and we know that they're going to be explained by, let's say, 10% of this. Okay, so let's multiply those two together. Multiply the seasonal constant times the number of sales. And which of these do we want to make sure we use an absolute reference on? Okay, we always want to use an absolute reference on something that we don't want to change as we copy it down. If we don't do that, we're going to be multiplying by nothing for all the other months. Now let's just see an example of that. It'd be kind of cool, wouldn't it? Look at that. Everything else is 0. Is that correct? No, just make sure you use an absolute reference on the year. So now when we copy this down, it's going to give us the correct values. What should this add to? If I add up all of these values right here, what should this add to? Yeah. Okay. If I add up the trend with seasonality applied, what should they add to? Exactly, because all we did is we multiply by 1. Okay, all these different weights all add up to 1. Therefore, we only multiplied by 1 according to different principles like commutative properties of association. So let's just go ahead and do a sum just to make sure we didn't mess up. I am certainly not infallible by any stretch. So let's add these up. And look at that, the same exact value. Isn't that pretty cool? So has anyone lost so far? Yeah, where are you lost? So to get the year 4 forecast, all you have to do is just take the previous year 3 and then just multiply it by the trend, which is 28% plus 1. Does that make sense? Any other questions? Yeah. I can't hear you, I'm sorry. I could take a look at it with you after class. Question? For what? I? Yeah, so basically in I, all you're doing is you're just taking the year 4, which is a predicted value, and you're multiplying by the seasonal constant to get which amount of sales is going to be inside of each month. So we're applying both trend and seasonality to our forecasting. All right, now let's do some actual forecasting. This isn't really that bad. Don't worry too much about it. So naive forecast for January. So if naive forecast for January is going to be the most recent occurring value, we just go down to year 3. It's just going to be this value right here, because that's the most recent occurring value. We're not accounting for any sort of seasonality or anything like that. Literally just use the most recent value. So year 4, January, is going to be 1895. Does that make sense? Okay, now seasonal naive. What are we going to do for seasonal naive? So we just go to the most recent January, which in this case is going to be 2797. So we just grab that. And that's going to give us our seasonal naive. Because we're just looking at the most recent period of the same type. So if we had December, we would look at the most recent December. That's all we're doing there. Now, of course, we're assuming that we're in year 4 on an exam. I may throw on there something where I may say, give me the seasonal naive forecast for year 2, January. So you go up to the previous value. So this is year 2, January. We know what the value is. But to predict it, we go up to the most recent occurrence of it. You can't use the value that's already happened. So you have to use one that's previous to that. So 2684 would be the seasonal naive if we were asked about what the seasonal naive forecast for year 2, January would be. Does that make sense? Because you definitely may see that on an exam. Okay, so simple moving average, like I said, just take however many periods you have. In this case, we're going to use a 3-period simple moving average. So all we have to do is just average the most recent 3 periods. Okay, so we just come down here to our data and just average these 3 guys right here. Okay, and of course that gives us 2131. Okay, weighted moving average, I'm going to assign some random weights. Actually, why don't you guys throw some weights at me? Let's make it interesting. What do we want weight 1 to be? 0.13, you said? Okay, because like I said, they have to add to 1. Weight 2. 0.28. All right. Weight 3 is going to be 0.13 plus 0.28 minus 1. So what is that going to give us? Should be 1, 4. So that's what these add to. So it should be, pretty sure it should be 0.59. I think so. Unless I messed that math up, which is quite possible. Let me just quickly double check that. So 0.13 plus 0.28 plus 0.59. Okay, did it right. Okay, so is everyone clear on the weights? We have 0.13, 0.28, 0.59. So all we have to do for weighted moving average, we're just going to go over to the data down here, take our weight 1, so that's going to be 0.13, multiply it by the most recent value down here. Now because we're using multiplication. This is going to happen before we do any addition, so we don't have to worry about parentheses. You can put them if it makes you feel better. So now the second weight is going to be 0.28. Multiply that by second most recent occurring value. And then lastly, add in the third weight, which is 0.59. And multiply that by third most recent occurring value. Just add those up. So like I said, weights are arbitrary. They must add to 1, but they're going to be given. Okay, so all you have to do is multiply the weights by their respective values. Does that make sense? All right, let's just do this. And of course, that gives us our weighted moving average. Last thing we're going to cover today is the simple exponential smoothing. So for this, you'll be given a previous forecast value, and you'll also be given an alpha. Alpha can be between 0 and 1, including 0 and 1. So someone throw me an alpha. What is alpha? .5, we can certainly do that. So we have 0.5, we have 1 minus 0.5, which is of course also 0.5. So go ahead and see an example here. So with this, we first use alpha to multiply by the most recent occurring value. So we're going to use 0.5 times most recent occurring value, which would be this right here. And now we're just going to add in 1 minus 0.5 times the most recent forecast, which we're just going to use for the previous weighted moving average. Okay, so we just do this, and that gives us our value. Okay, like I said, just use alpha multiplied by the most recent value, 1 minus alpha multiplied by the most recent forecast. Someone throw me a different alpha. One that's not 0.5. 0.7. I like it. 0.7. Okay, so we do 0.7 times most recent occurring value. And then we do 1 minus 0.7, which is of course 0.3 times most recent forecast. A little bit different. So with this, we're going to place more emphasis on the most recent occurring value, which is going to be less than the most recent occurring forecast. In this case. So we could literally use 1 here. And what we're going to do is we're going to take the naive forecast. So we're just going to use 1, and then 1 minus 1, which is obviously going to be 0. Anything times 0, of course, is going to be our friend 0. So, like I said, it's literally the naive forecast. Same thing there. Question? You'll be given the weights and the alpha in the problem. So, for example, if you're doing forecasting for a company, that's a good question. You would be given them. I don't think they really represent much of anything. It's just they have to add to 1, or they must be between 0 and 1. So let's say that a company wanted to place more emphasis on the previous month. They'd have a higher weight 1 than, say, weight 3. Let's say they want to place more emphasis on the most recent occurring value. They'd have an alpha that is going to be greater than 0.5. They don't really represent anything, like, in terms of, from a mathematical standpoint at least, but that's basically what we're doing there. All right, so that's basically all we have today. Like I said, next class we'll do some more examples. I'm going to stick around for any questions for about the next 10, 15 minutes, and I'm going to run to office hour. So I will be walking around for the next 10 to 15 minutes. Hope you all have a great day. Don't forget to submit the lab too.